this video is about properties of logarithms. In this video we're going to look at 3 different logarithmic properties that we use to expand. Expanding means that we are going to change from 1 log to be into many logs. Typically what happens when we expand is that the input of each log gets simpler. Alright, so our first log property is called the product rule. The product rule says if you have 1 log, and inside of that 1 log you are multiplying between 2 quantities. Each of those quantities gets to be inside of its own log, so we get 2 separate logs, and we are adding in between those logs. So this is called the product rule. So in our first example we have log base 4 of 7 times 5. Because we are multiplying between 2 quantities inside of a single log, this is going to be equal to 2 logs with the same base. So the base is 4. We're going to keep that same base of 4. We're going to be adding between these 2 logs of the same base of 4. The reason we're adding is because inside of that single log we are multiplying between 2 quantities. So this is a product rule because we are multiplying between the quantities inside of the single log. If we are multiplying inside, then whatever comes before the multiplication gets to go into the first log, and whatever comes after the multiplication inside of that single log gets to go into the second log. So we are adding in between these 2 quantities if we are multiplying inside of that single log. Okay, and that would be our answer. So this is using our log property called the product rule to expand from 1 log to more than 1 log using that product rule. Alright, the next one is the same. We have log, and the inside of that log we have 100x. So the implied operation between 100 and x is multiplication. The base of this log, remember, is an implied 10. When we expand this, we're going to do log base 10 plus log base 10. What comes before the multiplication gets to go into its own log. What comes after the multiplication gets to go into its own log. Now, can we simplify? So in this case, we can simplify a little bit more because we know log base 10 of 100. We would ask ourselves this question, 10 to what power would give us to 100? And the answer to that would be 2. So we can actually simplify this by writing 2. So we're going to replace this whole log with the 2. Because the question, remember, that we're asking ourselves when we evaluate a log is we rewrite in exponential form, and we say the base of the log raised to what exponent would equal to the input of the log. And we know that answer would be 2. So that first whole log simplifies to be 2. The second log can't simplify because we do not know what x is. So our final answer is 2 plus log of x. Alright, our next rule is called the quotient rule. The quotient rule says that if you have one single log where you're dividing inside, so flat line inside, we're dividing between 2 quantities, then we're going to have a flat line in between the 2 logs. So dividing inside 1 log, that input, dividing in that input in that single log, translates to be subtraction between the 2 logs. The top of the fraction gets to go into its own log, and the top is always going to go into a positive log. So the sign in front of this log is positive. The top of that fraction gets to go into its own log. It always goes into the positive log or the first log. The bottom of that fraction inside that single log gets to go into its own log but it always goes in the log that follows the minus sign. So we would say it goes into a negative log. Okay, that's the quotient rule, using the quotient rule to expand. Okay, I'm going to scoot down a little bit. Here I have the natural log of 19 divided by x. Okay, so since I'm dividing between two quantities inside of a single log, we're going to keep that same base, natural log. We're going to be subtracting, so flat line inside, flat line in between. Dividing leads to subtraction. Right, in the first log, we're going to put a 19. Whatever's at the top of that fraction inside of that single log goes into the positive log. The first one in front of the minus sign. Whatever's at the bottom of that fraction goes into the second log that follows the minus sign, so we would say it goes into a negative log. Right, and that's as good as that gets. In the next example, we have natural log of e to the power of 3 divided by 7. Since we are dividing, we see a flat line inside of a single log. We're going to separate this as two logs where we're subtracting in between them. Keep the same base, so it's natural log here, natural log, natural log. In the first log, we're going to put e to the power of 3. So whatever's at the top of that fraction goes into that positive first log. Whatever's at the bottom of that fraction goes into the second negative log. So into the second log, we're going to put a 7. Now, is there anything that we could do to simplify further? And the answer is yes. Natural log and e, the base of the log and the base of the exponential inside match. They cancel each other out. We're left with 3. There's nothing that we could do here. So we're going to simplify as much as we can without a calculator using the log, evaluating log rules that we talked about in the last video. Alright, our last rule that we're going to talk about here is called the power rule. Okay, the power rule says that, let's say you have any log of any base. Okay, I'm going to rewrite this a little bit. And you have your input of that log. And let's say that all of that input is raised to exactly the same power. If all of that input is raised to the same power, what the power rule says is that you're allowed to bring that power and multiply it times the front of the log. So it would look like this. It would look like power times the front of that log with whatever base, and the original input would be left inside. So this is what we call the power rule. If everything inside the log is raised to exactly the same power, then we are allowed to multiply that power out front of the log, and what will remain inside is just the original input. Alright, so we call the power rule. Alright, so let's look at two examples of using the power rule. The first one says log base 5 of 7 to the power of 4. So, when I look inside of that log, my input there is 7. Everything inside of that is raised to the same power of 4. So that means we're allowed to take the power off of the 7 and multiply it times the front of the log. So it becomes 4 times log base 5, and what remains inside is just the 7. Okay. Now we don't have to put the dot to represent multiplication. Sometimes you're going to see it as just 4 in front of the log. So 4 log base 5 of 7. So if you want to write it like that, that's perfectly fine. Now, I like this example here. You're going to see one like it in your homework. You want to be careful here. The power rule is not immediately applicable here. In this case, the only thing that exponent of 3 applies to is the y. Exponents only apply to what's directly in front of them. They do not go across multiplication. It's x times y to the power of 3. So the problem here is that my power rule only works if everything inside of the log is raised to exactly the same power. In this case, there's like an implied 1 as the power on the x, but that power of 3 does not apply to the x. So we will need to separate the x and the y first before we apply the power rule. So we're first going to use the product rule. The product rule says if you're multiplying between two quantities inside of a single log, you can separate those quantities into their own logs. Multiplication translates to addition between the two logs. In the first log we will have x, in the second log we will have y to the power of 3. Now we are allowed to use the power rule. In the second log, we have that y now. Now that y is raised to the power of 3. So in that second log, everything is raised to exactly the same power of 3. So I'm allowed then to bring that 3 and multiply it out front of that second log. So it becomes 3 times log, and what's left inside is just the y. So the 3 comes out front, and the y remains by itself on the inside. Alright, so this is called using our properties of logs to expand.